Welcome back to another Daishinfinity video. In this video, we're going to talk about the derivative of the inverse of cosecant of x. Now, it states that the derivative of the inverse cosecant, which is also the same thing as 1 over the inverse of sine, so the arc sine, is equal to negative 1 over the absolute value of x times the square root of x squared minus 1. So in this video, we're going to try and prove this. Before we dive right in, we have to talk about the limit definition of the derivative. The derivative of any function f of x is given by the limit as h approaches 0 of f of x plus h minus f of x all over h. Now we're just going to plug in the cosecant inverse into the f of x. Now the derivative of cosecant inverse is the same thing as the derivative of 1 over the inverse sine of x. So I'm just going to let f of x be inverse sine of x and just plug in the limit as h approaches 0 of 1 over the inverse sine of x plus h minus 1 over the inverse sine of x all over h. Now, normally, if I have this kind of limit, I would normally put the fractions together and then put the h also into the denominator. But the problem with this is that we cannot go further with it. Either you go further and then you have to take a long time until you get to the final solution, or we are very smart and just use some small substitutions. But before we use some small substitution, I would like you to let you know that there's a inverse trigonometric property that we can use over here. It states that any inverse sine or inverse cosine or inverse tangent function, which is under the 1 over something, is just equal to the sine, so the arc cosine, to the negative 1 power, that this is equal to inverse sine of 1 over x. This has something to do with the unit circle, so we have to take care of this in another video, but just believe me that this property holds for x. The interval, I'm not really sure about it, but let's just hope for it. So now we can use this property to plug all of this into our limit. So it will be our limit as h approaches 0 of this inverse sine of 1 over x plus h, 1 over x plus h minus inverse sine of 1 over x and then all over h. So since we have this, we can now substitute something as another function. Now the question is, what are we going to substitute in? Now since we know that h approaches 0, we know that inverse sine of 1 over x plus h will also approach inverse sine of 1 over x. So I think the best option is to substitute 1 over x as another parameterized function. So we would just let u of x, let's call it u of x, equal to 1 over x, so which is depending on x. Now if I take the inverse sine of them on both sides, inverse sine of u of x, then I would get the original form. Now this is found in the limit also. The limit is found here. So we have the inverse sine of 1 over x. But we also know that the normal structure is called limit as h approaches 0 of f of x plus h minus f of x over h. So f of x is simply equal to the inverse sine of 1 over x. So we can just write that the inverse sine of u of x is equal to f of x. So this is the full function f of x. Now what we're going to do is we're going to use the chain rule and derive or just differentiate on both sides, giving us the f prime of x is equal to the derivative of our inverse sine function of u of x. Very simple. What are we going to do? We are just going to take the inverse sine derivative and multiply by u prime of x. So what is the derivative of sine of x? The derivative of sine of x is in another video, you can already see it, is 1 over, now, the square root of the x squared minus 1, but our input is u of x, so we have to write the 1 minus u of x squared. Multiply that whole thing by the u prime of x. So this is what we are getting, and u of x is equal to 1 over x, so let's just plug the whole thing in. So we just have 1 minus 1 over x squared times the derivative of 1 over x. Now what is the derivative of 1 over x? 1 over x is the same thing as x to the negative first power, so we just have 1 minus 1 over x squared here times negative x to the negative 2, which is 1 over x squared. So we can just bring the negative to the front and put everything together. So we just have negative 1 over x squared times 1 minus 1 over x squared. Good. Now what we can do is we can still simplify many things. What we can do over here is we can bring the x squared into our root. Okay. Now what we're going to do is we're going to take one of the x's. So negative 1 times x, right? Times the square root of 1 minus 1 over x squared. Now x squared as a function, if you look at the function x squared, it is always positive, except at x equals 0, which is 0. Which means if you want to split the x squared into the two x's, we have to take the absolute value on both sides. So I'm just going to put this one in, which is simply equal to the square root of x squared. And that is equal to the absolute value of x. So we can put this one just in here, simplifying everything out. So we will just have negative 1 over the square root of, the absolute value of x times the square root of 1 minus 1 over x squared times x squared. Since we put in the absolute values inside. So we have negative 1 over the absolute value of x times x squared minus 1. And that is f prime of x, or the derivative of cosecant inverse of x. So we have just proven that the derivative of the inverse of cosecant of x inverse is equal to negative 1 over the absolute value of x times the square root of x squared minus 1. Thank you guys for watching this video. Please like and subscribe, and I hope we will see us in the next Daishinfinity video. See ya.